just between myself and Chris Underwood, there's over 50 years of doing this. Chris is an excellent install guy. I'm more the theory and making sure that the sound, the design goes in as it's supposed to. We've been with Cedia for over 20 years. And this group is used to dealing with people who aren't necessarily acoustic experts. And I think that's important. The commercial side of things, where we always, all of our reps have been doing this for a long time. But if you've never done this and it's a little bit intimidating, we can make sure you get it done. And I will say this, Watershed is a wonderful partner. They've really taken ownership of the Canadian market up there. They carry inventory. They really make it easy for us to help them and then for them to help you. Additionally, we also have lots of consultant relationships. So if it's beyond our expertise, you can always reach out to us and we can recommend several different consultants that are available. So as mentioned, we're going to talk about home theater acoustics. There are going to be a lot of terms. There are going to be a lot of products. That's a good thing. A lot of rules. And fortunately for everybody listening in, all that kind of translates into the ability to make money. Kinetics is going to do this a little bit differently than a lot of other people in the marketplace. We have the ability to take this to whatever level you want to take it. If we can put the Dallas Convention Center on a set of springs and rubber pads, we can certainly isolate your home theater to whatever level we need to. So again, as mentioned, like this week, we're going to try to cover the noise control, the sound isolation side of things. Next week, we'll do the room acoustics, the finished goods side of things. But basically, the difference is we're talking about building materials and ultimately on the noise control side of things, something squishy. That's the technical term that I'll try to use today. From the room acoustics standpoint, it's either kind of absorption or reflection. So we'll do a little tiny bit of some background information, talk about frequency and sound a little bit. You're probably pretty familiar with this, that basically, if you look at an oscilloscope and a sound wave, the further it is from that center line, the louder it's going to sound. And the broader the wavelength, the lower the frequency is going to be. And if we look at kind of the spectrum of what we can hear this full range up to about 25 years old. And then what happens is your eardrum starts to actually get a little bit stiffer, and these higher frequencies just don't have enough energy to make your eardrum vibrate. If your eardrum doesn't vibrate, you can't hear it. And by the time you're 80 years old, you've kind of lost a lot of that high energy sound. This is why when you see a lot of the standards and you see a lot of things for even home audio, you don't see them concentrating on frequencies up here because frankly, you can't hear them that well anyway. It's really down here is where the bulk of the speakers are going to do their thing. There are super tweeters out there, but they're as much for scientific research as they are actual home theater devices. When you kind of look at these, we kind of call these the golden frequencies from 125 up to 4K. And the reason it's kind of a kinetics term, the reason that is that's kind of where all of the sound tests are going to kind of focus where they operate. And you can kind of see right off the bat, as far as we're concerned, they don't even cover areas where a subwoofer is going to play. And again, they kind of ignore these higher frequencies. A lot of this has to do, this is kind of the voice frequencies. And it also, frankly, when they were establishing these standards, that's where the lab could actually record these frequencies. And again, it's important to keep in mind when talking about anything music or theater rated, that things have a frequency range, a two-little range from here to here, a flute and a cymbal. And again, we're outside of these golden frequencies, even with a basic tuba instrument. Also talk about, Johnny Cash to Mariah Carey, there's your voice range. And then of course your subwoofer is going to be way down here. What's going to be important to our discussion today is kind of an understanding of these different wavelengths. As you can see, 20,000 hertz is 0.7 inches. And way down here at 20 hertz is a 55-foot sound wave. And frankly, when I'm using this slide and talking to architects, I bring up home theaters as an example. This is why traditionally in a 5.1 setup that you only need one subwoofer. And the reason is your head is physically sitting inside that 55-foot wave, so it's not very directional. As opposed to something like this where it's quite small, your ear can pick it out. That's why you need right and left surround channels, is because of the size of the wavelengths. So today we're going to talk about sound isolation, and Kinetics has kind of coined the phrase retain the experience. And we need that from very much a marketing perspective. We want to make sure that not only are you paying for that escape, that theater experience, we also don't want the real world coming in and bothering you. So it does kind of go not only bothering the rest of the house, but also bothering your experience. That's what we mean by retain the experience. Keep it inside the theater and keep the outside out of the theater. And if you kind of look at the whole home, what do we mean by all that? Some of these things are going to be what you would expect, and some of them maybe not so much. So incoming noise, obviously someone say dragging a chair across the floor, that's pretty obvious. Someone flushes a commode, that's going to bother the experience a bit. HVAC noise might not be something you would think of off the top. And even traffic vibration, truck and traffic, even train vibration can come in and bother you while you're listening. And at the same time, you've got noise obviously going to go through the ceiling into the floor above. It also can travel through the structure and do kind of funny things and break out in funny places. We'll take a look at that. And then one nobody might think about is basically traveling through ducts. You certainly wouldn't want that rated R dialogue going into the kids' room late at night. Walls are a special case. We'll kind of break those out and talk about those kind of specifically. So the 1, 2, 3 of high performance noise control, there's a couple different ways to cut this cake up, but for high performance, we're going to kind of break it down into 3 things. The first being mass, and that's just mass of any kind of building material, drywall, concrete, plywood, finished flooring, all that stuff is kind of the mass of the assembly. And basically what happens is it goes through that mass and becomes less energy on the other side. The second ingredient is airspace, and people don't understand how important that is. But if we take that mass, kind of split it in half, like we would say over a stud cavity or a joist cavity, we can kind of increase the performance of the noise of the mass by itself. And by that, basically, airborne noise is going to hit that, say, first layer of drywall. It has to become structure-borne vibration to pass through to the other side. If you think about it, if there's a wall between you and me, it has to go from airborne to structure-borne. It's going to break back out as airborne, turn back into structure-borne, and then finally break out on the other side as airborne noise. And having that airspace does do some wonders for how much of that noise breaks through on the other side.
Oh, okay. So I have 2 stuff to
The last key ingredient, though, is the resilient decoupler. And basically what we want to do is break the structure-borne vibration on one side with something squishy. And generally speaking, the squishier it is, not only the better is it going to work, but to the lower frequency it's going to work. So for example, a 1-inch spring isolator is going to work better than a 1/2-inch pad isolator. When we kind of look at the effect of how this mass airspace with something squishy in there works with mass, the general rule is that for every time you double mass, a barrier will reduce sound 6 decibels. So if we look, for example, a 6-inch concrete slab in a high-rise tower, at 500 hertz, we'll actually knock down 52 decibels of noise. So if we double that to 12, it's going to reduce it to 58. If we double it to 24, it will reduce it 64. But if we go back to that original 6-inch slab and add something isolated with a 1-inch, say, spring hanger and a couple layers of drywall, this 20-inch assembly with much less concrete will actually reduce things 84 decibels. So sometimes when I'm showing off our fancy ceiling hangers with these springs and people think it's overkill, like, it really is, what are you trying to achieve? But you can, for that money, get much, much better performance than just adding mass by itself. The most misunderstood principle is that I'm going to put panels up to block noise. It simply doesn't really do that. What happens when you do use an absorber is a lot of the energy happens when it hits that drywall and bounces back, and you kind of get this change in mode, and that's where this energy is being transferred into heat. But that initial wave is going to basically break through that fiberglass, hit the mass, turn into structure-borne vibration, and bounce off. What panels do is basically treat anything that's reverberating inside the space. And again, we'll talk about that more next week. That said, putting fiberglass in the air cavity does actually have advantages. And if we kind of zoom in on what was happening inside a wall, that basically that sound energy is going to kind of come in, and these loose fibers, you want to use a cheap fiberglass, or actually up in Canada, I think mineral wool is much more prevalent, but it's the same idea. You don't want to get a dense one, just a loose fiber one. And basically it's going to make that sound kind of bounce off those fibers and bounce off those fibers. And every time it's bouncing, it's losing a little bit of energy, and it's going so forth and so on. And if we take these line segments and add them up, we've just actually made it so it takes that sound wave longer to travel through there. So we've effectively increased the airspace. This is why in the car audio world, you put fiberglass inside of a bass box when you can't build a box large enough for that speaker as the specs are driven. It's because you're basically tricking the air into thinking there's more in there than it really is, and it's through this effect. Additionally, obviously, it's going to kind of radiate off that hard surface and go back and forth and repeat. So that's why putting fiberglass in the cavity does help, where putting fiberglass on a wall does not. Next, we'll look at some sound, and I'm going to have to turn on my audio here. So you can hear it. We're going to look at some background pink noise just as a reference. I trust everyone can hear that. If not, Scott will tell me. Let's knock it down 3 decibels. So 3 dB is about as much as you can hear a difference of. If we do 6, we call that noticeable. 10, because everything's logarithmic, is basically half. 20, you might even have problems hearing. Now this is pink noise, and pink noise by definition is a collection of frequencies. So using the term decibel is appropriate. It's also probably my least favorite acoustic term, because everybody in the world knows what it means, but really when it comes down to it, they don't know what it means. And the reason is because we're way more sensitive to high frequency sounds than we are low frequency sounds. And that's exactly what this chart is showing you. It's kind of the threshold of what we can hear. And basically, if I played for you something at 2000 hertz, you could hear it at 3 dB versus at 63 hertz, it would have to be 35 dB, and it would sound the same level of loudness to you. So kind of a real world example of this. This is why subwoofers need those giant amps, because you got to get that sound way up to 100 decibels and need all that power to kind of match the easily obtained power at, say, 2000 and 1000 hertz. But people don't take this into effect. I get this call from architects all the time when they have a piece of noisy equipment. Hey, I need to knock it down 20 dB. And my first question is, at what frequency? And they never know, because everybody knows what decibel means, but really no one knows what decibel means. So kind of moving on to the products, this is kind of the shot from our webpage on the noise control side of things, all these different products. But basically it does break down in these categories of floors, ceilings, walls, ducts, and kind of some miscellaneous items. We're going to cover kind of the highlighted ones today. We're not going to try to go through them all. And one thing that I think makes a lot of sense for the Canadian market is from a good, better, best standpoint, basically Watershed brings in our rim system, which is in the best line. And what makes it the best is these pads, which is actually the foundation of our company, create an airspace between the floor below and a new deck above. In this case, they're putting down a sheet of plywood and they're going to pour concrete on it. What this pad really lets us do is, between the type of pad we use and the spacing, is kind of dictate that performance. And to kind of go down a rabbit hole without going maybe too far, is this kind of shows you something very important about this system. And that is, it has a very, very, very low natural frequency around a long, long, long load range. What does that mean to you? If you use this product even on grade or in the bottom of a basement, it's going to help prevent that subwoofer getting into the structure of the house. It's going to help truck traffic driving by from breaking into the theater because it does isolate very, very low down here. You know, the subwoofer cuts off at about 20 hertz. We can isolate down to say 8 hertz if we balance it right. So a very, very good system for floors. It's the foundation of everything. If you do it right with the pads, you can actually build the whole system on top of that. It's that room within a room concept, something to keep in mind. We'll look at that here in a little bit, but really good. Makes sense to bring that across the border because it ships easier than the other products, which are board products. And between the 1 inch and the 2 inch, we can really dial in that performance to wherever we need to go. That said, with the ceiling, there are a couple different options, and keeping in mind that the lower or the more squishy it is, the better it's going to perform. So our best one would be a 1 inch deflection spring hanger. That's our ICW. You see it on a wood joist. Think like coil shocks on your car. That full 1 inch deflection means it's going to isolate all the way down to 3 hertz. So it's going to do a really good job not only of capturing the theater sound, but it's also going to do a good job of preventing high heel noise walking across and breaking into the theater space. It is a higher priced object. If you need to move the next step down, the wave hanger, if this is a coil shock on your car, this is a leaf spring on your truck. We're looking at a 1 inch deflection versus a 1/2 inch deflection. The performance is pretty good. It does go down to 5 hertz. Doesn't quite attenuate as much as this does, but there's also a big budget difference. Last but not least is our Isomax clip as a ceiling isolator. Not the best performance in the world because this joist creates a big airspace for 12 inches, and this just isn't very quote unquote squishy. It's a little bit of a rubber pad. Definitely better than nothing. This thing works wonders in walls, as we'll see, where you don't have as much airspace. But from the price differential between this product and this product, this is about the same and the performance is much higher. So if you're talking to me, I'm going to recommend either one of these two 99% of the time. The one advantage this does have is it does make for easier installation versus some traditional methods, which we'll talk about when we get to the walls. Anytime you're building anything isolated, be it a ceiling, be it a floor, you do have to kind of pay attention to some of the tricks of the trade when installing these things. Number one is we're basically trying to isolate, in this case, the drywall with this ceiling hanger. We want to make sure that that drywall doesn't touch the deck or the sidewalls at all. And here you see what we kind of call a resilient interface going there, and then we kind of finish that off with an acoustic sealant. Same kind of idea with the floor. You want to make sure if you're isolating the concrete or wood floor that it's not touching the walls so that thing remains completely isolated. Additionally, if you're building a system, you want to make sure that the sound cannot flank around either these nice systems that you're putting in. So in this case, if we have a noise source, the ceiling is doing a good job of preventing that noise. The wall or the floor is doing a good job of preventing that noise, but the sound can get right into that wall and flank around it both for top and bottom. So again, with the rim system, build your wall on top of there, you'll take care of that problem. And then we'll talk about some treatments you can do up here. Interestingly enough, when you talk about the commercial building code, there is no requirement for treating flank with glass in the United States, but Canada is well ahead of us. And there is actually in building code for residential construction, you do have to not only use sound abatement treatments, but you have to control flanking paths as well. So let's take a look at kind of walls and kind of do a scenario with the child that's going off to college and you want to create a little media room in the basement. So you're going to move some furniture around, you're going to put a wall in place, you're going to put your isolated ceiling in and your isolated floor in. And now you've got your noise source. And again, we've kind of treated the top, we've treated the bottom, but we're kind of getting into the walls. So what I'm going to try to illustrate with a couple different product examples is treating for noise versus treating for structure-borne vibration, right? So right now we've got a structure-borne vibration product from going into the structure here as well as into this wall and breaking out that way. So in scenario one, we're going to look at basically creating a wall right here on the side. So we put up some what's called a sway brace, and we build a false wall on top of the floor, and we make sure it does not have contact up top. And when we look at how this performs, we've broken it there. And this is the particular product. It holds the wall off of it, and you've controlled any vibration from going through to that wall on this side. On the other side, though, we still have this problem, and this is already built. So what we want to do now is basically control it top and bottom by making a break there and adding a pad, as well as doing it on the floor and adding a pad on the bottom of the wall. And this happens to be our CWCA product, as well as our wall mat. So basically what we're trying to do is create a break. These products don't make these walls quieter. These products just basically make a transmission path break where that structure borne vibration can't go from that stud into the structure below or up into the structure above. And of course, if you're going to have a fastener to fasten your wall down, you better isolate that fastener too. And that's what you're seeing there. That happens to be our KAI isolator. So that's kind of scenario two. We have a stud wall here, and we have an isolated wall here. Well, of course, the person comes home from college, moves back in, and now we've got a noise problem because we haven't really treated that wall for noise. We've just stopped the noise from going up and down. In that case, we actually are going to want to isolate the drywall with an actual product that will do both noise control as well as vibration control. And here you can see we've completely stopped both the noise as well as the vibration. So traditionally, you may have heard of resilient channel. This was actually invented as a crack suppressant back in the drywall days. And when they sound tested it, they noted that it actually had some sound properties. It gets poo-pooed over the years, but the fact of the matter is you can get some performance if you use the right brand. That's the problem. It does that. It has to be this one. These other products don't work nearly as well. Also, you have to make sure you install it correctly. It's really, really easy to accidentally use a wrong screw and then connect that drywall through your resilient channel into a stud. The other problem is half the contractors don't understand that it has to kind of fall away from the wall in this case and not push into the wall. And they estimate that at least 50% of all installations are installed upside down. And it only takes 6 errant screws to make the wall completely worthless and not use it. And that's why a much better product is the Isomax clip that we looked at for the ceiling. Basically, what it gives you is the same noise control performance as a double stud wall that you use between, say, two apartments in a more compact package. And you cannot mess it up as long as you spec the right screw length. So it does perform better than resilient channel. It is very much easier to install than resilient channel. And it actually is less expensive to build this wall than it is this wall. And it saves you 3 inches of space. It does very, very, very well. Dollar bang for the buck, the best bang for the buck product we ever have. On the commercial side, if an architect only has 30 seconds to talk to me, I talk about the Isomax clip. We talked about the first most misunderstood principle in noise control being use fiberglass panels to block noise. The second most misunderstood is not understanding how airspace is a function of this. So if we were to look at a common wall, it has what we call an STC rating. It's a sound transmission class rating of 33. That's very bad. If I was talking at a normal volume, you would be able to hear everything I would say on the other side of that wall. If we come up to that existing wall and put an Isomax clip right on there and add another layer of drywall, we can go from a 33 to a 46, which is a very, very good improvement with just 3 layers of drywall. However, a 46 is not that good. If I was talking or yelling on my wall, you would definitely hear it as I was saying on the other side. If I was playing music, you would hear it. If, however, we use the same ingredients, these 3 layers of drywall, and take 1, 2, 3, but put an airspace all the way from here to this layer of drywall, we actually get a 61. And so this is kind of my cautionary tale to everybody when talking to people about acoustics. If they claim to have a miracle product, they don't. It's always going to be the assembly. It's about mass, it's about airspace, and then it's about squishiness and making sure you understand how that entire assembly works. So that's kind of the guide for high performance noise control. You may have heard of products out on the market like Green Glue. We offer a version called Sound Amp 2 of the same thing. This product works very differently than this mass airspace mass. What this does is you're actually shifting the natural frequency of the wall materials. My best way to try to explain that is if you ring a dinner bell and then put your finger on the bell and how it goes clunk instead of ding. That's kind of what this damping material is doing, is it's shifting it to where we're not as sensitive to it because it's a lower frequency. It can work. However, what people don't understand is your studs have to be spaced at 24 inches on center. They can't be at 16. And that's usually a downside because obviously 16 is much more common than 24. You need the mass of those layers of drywall between those studs for it to work. So if someone calls me up and finds this product and says, should I use it if I can't use a clip? I'll ask them if it's 16 or 24. And if they say 16, I'm like, just put another layer of drywall up. If they say 24, I say definitely use the damping compound, put it on there. It will make a difference. So kind of bringing it together, room within a room, you want to make sure there's no hard connections. It is all about planning. I know that can be a challenge in the home theater world because a lot of times some of these things will already be built. So obviously the better you can get in there, the earlier is going to be better. Let's take a look. I don't know if anybody's heard of the PAC clip. They kind of compared their version of the ISOMAX clip to our version of the wave hanger. And they basically said we're a point better for airborne noise and we're a point better for impact noise. But if you kind of break it down and look at this construction, you can kind of see how this game is played here a little bit. So if we compare their construction versus ours, they used a Pergo system. We used engineered hardwood floor. So technically we have a little bit mass. So this system is probably a little bit better from a noise control standpoint. They built that flooring on, in our case, we used a 3 millimeter layer of rubber. They used a 2 millimeter layer of rubber. 3 millimeter should be a little bit squishier. So far this assembly should actually be better. However, here's where we used a single layer of 3/4 plywood. They used 2 layers of 5/8 with a membrane in between it. Much more mass, much better system for noise control than just a single layer of 3/4. The one that really throws people off, though, is the fact that their joist was at 16 inches on center and ours is at 24. That might not make sense from a mass standpoint, but from a stiffness standpoint, this system is much more stiff. So any kind of noise control from an impact standpoint, it's kind of comparing a snare drum versus a bass drum. That snare drum being tight is going to reflect that energy a lot much more than the bass drum is. It's a giant advantage to be at 16 versus 24. Lastly, they used a type C drywall. We use a type X. Type C is for fire code. It's a little bit denser. But given all of those things in their favor, frankly, the fact that they only got a point is kind of questionable. And then it's also kind of comparing something that a spring to a piece of rubber. My comment is either they're being deliberately deceitful or they're ignorant. And I happen to know the owner. I know he's not ignorant. So that kind of takes care of floor, ceilings, and walls. We'll look now at ducts. This has been a very much in-demand product for us. We show these things off at CEDIA. It always gets a lot of attention, and then we wind up with a lot of activity afterwards. Unfortunately, I can't do the demo for you, but it is a remarkable demo of how well that our products can perform. But in a situation, you have 2 things going on here. One, you have noise from a furnace that's going to break into the room and bother the experience. And then, as mentioned earlier, you might have that rated R soundtrack kind of going out of the theater and breaking out into the rest of the house. And this is where, right outside that theater wall, you do want to put in a duct silencer. And what that will do is basically treat both noise going in as well as noise going out quite effectively, actually. The problem in this scenario, though, is you've kind of cut a hole in your mass system for your ceiling, and that sound now kind of goes up and then is going to break out of this low mass ductwork and get into the cavity and break into the area above. And that's where you want to treat that with a mass wrap system. This is a 1 pound per square foot barrier system. You do want to have a fiberglass pad on top so you prevent direct contact between the duct and the wrap. And when you do that, you've now treated that whole space and the sound is completely treated. You've taken care of that hole in the ceiling. Another area is kind of weak links. One, can lights in the system. You're putting a hole in the mass, so you want to replace it with mass speaker boxes or light boxes around that box. You just want to make sure that when you spec a light out, you spec one that can take the heat of being sealed like that. Additionally, anytime you have a light switch or an outlet, you want to make sure that you're coating the back of it with that mass, because you've removed that drywall mass from that system. Doors, we actually do sell full-size doors, but at the very least, they do make sweeps that when you close the door, they come down and prevent that noise from going under that door frame. Additionally, you guys can sell anywhere into the home, and we are a one-stop shop. So things like using our unibraces to isolate garage door openers is definitely available to you. Getting into fans and attics is definitely is a source of structure-borne vibration that not many people think about. And the idea is basically, call Watershed, they'll get with us. And if it's a wine cellar that's a vibration problem, we've solved that kind of thing. It just doesn't have to be anything, just the home theater. We can kind of help with anything. Maybe it's a nursery room when they're building. With the home office craze now, that's something to keep in mind. And in fact, that's kind of where we begin to wrap everything up here and kind of go back to our main model where we talked about chair dragging and plumbing noise. Put that marketing spin when you're talking to your clients and say things like, we want to get rid of experience disruptions. Things like kids stomping on a floor, toilet water gurgling. That's a nice descriptive word. Truck and train noise. We want to maintain quiet. And this is kind of how I would go about positioning things when talking to a homeowner. And that is to say, if they don't understand why a theater down here, it might create noise through the floor. If this is something that they really can't understand, at that point in time, it's probably better to just stop the conversation about noise control and start talking about what we'll cover next week, and that's room acoustics. Because this is really, really basic stuff. I mean, it is going to bother the rest of the house. If, however, you do, get your bite and they understand that, the next thing to kind of ask them a question about is their piping. Is everything cast iron? And you're actually kind of hoping they say yes, because if they say, yep, it's cast iron, you can say, oh, good, we don't have to worry about that. You've just built yourself some credibility. If they do say, no, it's PVC, you say, you know what, we'll come back to that. Let's talk about some other things. But when you do come back to that same pipe and duct, or that duct wrap that we talked about in the previous slide, is the same kind of treatment you would do for PVC piping. This is more of a discussion that's on the finer elements, but you do want to make sure that you talk about that subwoofer getting into the structure and breaking out into the rest of the house. the fact that we're now pushed back to home offices makes this conversation a little bit easier. The kids come home from school, they're playing video games, mom is working up in her office and she doesn't want to be bothered. That's a much easier sell than just trying to say we're trying to keep the subwoofer from getting into the structure of the house. Dad wants to watch Avengers, mom wants to read a book, same kind of idea. We're trying to keep that from breaking out. Again, maintaining the experience of the isolated room for both the user as well as the other people in the house. And again, the traveling through ducts, no one wants, that rated R movie getting into the kids' room. So bringing it all together, we want to kind of retain the experience. And my best tips for you are to plan before construction, plan before construction, plan before construction. I can tell you I've had so many conversations with architects where 6 months after I've talked to them, they call me back and they say, well, we built everything, we're having complaints, what are we gonna do? And I say, well, you've got to tear down your drywall and put something in there. And they're like, what else can we do? I'm like, it's physics. There really isn't much. You've got to stop that structure-borne vibration in that construction somewhere. And how do you do that? Well, it's basically something squishy. Again, this is where just reach out to Watershed. They are experts. They'll get with us. They're really, really used to it. They keep a lot of this stuff up there in stock, and they can kind of talk you through the process of making this happen. And one thing I didn't mention is we do offer full engineering support for these things. You're not going to be on your own. You're going to get a full set of drawings on how those things all lay out. We'll take care of all that for you. So with that, I actually finished 3 minutes early. Who's got some questions for me?
Jason, that's great. I really like that last part about being for the home office and everything else. This is not just theater product. Although that's primarily where we get started with conversations on dealers. But the dealers that have embraced this category for not just the theaters are the ones that are having the most success with it. Everybody needs to pay attention to this because it is a growing category, and it does get you into the jobs and those conversations much sooner, so that the dollars aren't being spent elsewhere. So with that being said, obviously we're complete here, but if anybody has any questions while Jason's on the line, he's more than willing to answer them. If you're not comfortable speaking, you can also type into the chat. You can also email me or your sales rep. If it's not me, Tracy or Steve, we can answer any questions you have.
I have a couple questions.
Excellent.
So I'm just curious about two things I noticed. One, what do you do about, I know there's the backing you can put on light switches to add mass, but is there anything because for a light switch, for example, you screw the light switch into the box, like you have your floating wall, which the light switch would be pressed up against technically, but then you're putting the screws for that light switch into the metal box, which is connected to the stud space. Is there anything that's supposed to, like any rubber you're supposed to use for those screws, or to stop like between the light switch and the metal box, or how does that work? And you're creating that open gap for the.
That's a great point, because it would represent a short circuit. There are extensions you can buy. We don't make a specific isolator for that. The idea being that's you got a hole in the wall anyway. So yes, it's a short. Yes, it's a great question, but you've already kind of created a problem there anyway. We are adding some of that mass back, but we're not adding as much mass as we are taking away. Those little boxes, those little wraps aren't nearly as much. So it's not something we specifically sell. We could make that product. I can't say there's been much of a demand for it though.
Right. Yeah.
But more key is getting that thing sealed up with the extension. That's a great point.
There is sorry, Jason, there is a solution for that. It would just require kind of an advanced or thinking ahead before the walls and everything goes up. But very similar to if you were hanging a TV on a wall that was floated with Isomax clips, you'd use our Unibrace product and a sheet of plywood so that you have something to screw that into. And you could also do that with J boxes. You could use our Unibrace plywood sheet and then the J box into that. So that is a possible solution. The biggest difference there is your J box isn't, if there's just one or two of them on a wall, the short circuit there isn't going to really amount to much effect on it. Whereas, let's say you were doing a 65-inch TV and you're screwing a bracket in, you're going into 3 different studs, that would definitely be a short circuit that we'd be worried about.
That's a good point. I've actually never heard about doing that for electrical, but there's absolutely can, and I'm going to try to show you this drawing here. This is for plumbing, but it's the same idea. What Scott just mentioned is you're basically going to use the Unibrace to isolate. We're showing metal here, but it could be a wood stud. And then basically that thing is completely isolated through the Unibrace. And whatever you hang onto that is isolated.
That makes sense. All right.
You can run that either direction, actually. Yeah.
Quick.
It's also why you have to be there in there early to work on these things with the builder or the contractor.
Got it. Quick other question that I just noticed when you're talking about the venting in a room. There's that wrap that goes around the duct or the piping out to the silencer, but in that scenario or that slide, when you have that vent in the ceiling, you don't actually wrap the vent itself.
You can actually.
That makes sense.
You can.
Oh, can you?
On the back of it, yes.
Okay, that makes sense then.
And I didn't mention it, but if you're ever doing the design, those ribbon diffusers that are long and skinny are much quieter from an airflow standpoint than the square ones. So if you get an opportunity to spec those out, that's the way you want to go.
And on the HVAC thing, if your return can be configured so that you can use a standard silencer, that's great. But if your return air vent is in a stud space and then up into something that breaks out from there, we can custom make silencers. In fact, we do it quite often, even on the feed. We can custom make silencers that are smaller, larger, longer, what have you for each purpose. But again, getting in there on ahead of time before the HVAC goes in is beneficial to you to sell this product.
Yeah, I mean, we have a whole division. That's what they do. So we can do, if there's an airdrop concern, we can do whatever they need to do. We can kind of balance acoustic performance versus airflow disruption if it happens to be in the middle of a chain.
Thanks for your questions, Cale. Anybody else? Nope, pretty quiet crowd today.
Well, I should conclude by saying I really did like way oversimplify all of this. Hopefully we'll get all these travel restrictions here gone, and we'll head up to your side of the border and we can do an in-person training at maybe a place that offers a frosty beverage or something like that.
Yeah, and just so everybody knows, it's always an open invitation. We have a small structure here in our office that goes over a lot of the products that Jason spoke about today to give you a handle. If you wanted to bring a contractor with you to the office to talk about that stuff or see how it goes in, we're more than happy to host you, your staff, installers, contractors, architects, anybody that you want. And again, if you want us to go out to meet with contractors or architects or builders, we can bring a lot of stuff on site or meet at your office to have these discussions. So Absolutely. Get us involved as much and as early as possible.
Yeah, you guys are actually pretty fortunate. I would say Watershed is probably our most knowledgeable from a home theater construction standpoint of any of the reps we have in North America. So.
Thank you. Okay, well then that's Jason. I appreciate. We'll talk again next week. I'll let you know if there's any other questions that come through that we can't answer. And I guess that's it.
Yep, we'll have fun with the next week's stuff. We had some new products that we brought out at CEDIA to talk about. We do things very much differently than the rest of the rest of the world. So we hope you'll join us for next week's conversation too.
Perfect. Thank you, Jason.
Thank you.
Thanks, Jason. Really appreciate it.
No problem. Thanks.
Bye, everyone.
Thanks.